Okay, hello everyone. My name is Wang Xi and from Keio University, Japan. I'm glad to be here presenting my work in progress paper, Lower Face Impending Ambient Face Recognition under Occlusions. I would like to first talk about my motivation to conduct research. At the time of presenting, COVID-19 has been rampant for 2 years, and people have begun to consider masks a necessary and inevitable tool as the pandemic has increased considerably. So many diverse smart devices have also been affected because the occlusions caused by mask wearing have hindered or totally incapacitated facial recognition. So basically, people are facing the dilemma to either take off your mask and suffer from the risks of infection, or just totally tolerate the disability of facial recognition. An instant implementation with high accuracy and reliability has been missing, but fortunately, researchers around the world have been paying keen attention to this and conducting experiments to solve this urgent problem. So this research proposed a novel approach to remove lower face occlusions such as masks, and we call the system identity-aware reconstruction and recognition, which is IdReco for short. We introduced an identity-aware loss function term to improve the pure generative method. So as you can see, here's an overview of the system's flow. The original datasets are first automatically masked, and the masked portraits are input into a generator for reconstructing the lower area. So at this stage, except for the traditional GAN loss, we also introduced a pre-trained recognizer to calculate an identity loss by comparing the differences between the reconstructed ones and their ranges. So after the reconstruction, the reconstructed faces are put into an extractor, we called it, to extract the feature embedding. Then the distance between the extracted features and the anchor feature embedding, which reached by calculating an average of all target faces, is calculated. If the calculated distance is lower than a certain set threshold, it will be deemed as qualified in the identification phase. So here are some current solutions for this kind of dilemma, which are attention-based methods and impending-based methods. Also, like some researchers used hybrid datasets or like wearable devices can be a direct solution. But however, they both face different difficulties in terms of facial recognition and lower face occlusion, such as the attention-based methods usually suffer from Q loss to different extents, while the impending methods lack similarity between the generated ones and the original ones. Okay, so to solve problem addressed above, we introduce a novel approach, IdReco, because traditional impending algorithms are unlikely to predict an authentic output regarding the dense facial information loss. So we use structure-guided impending algorithm to overcome this kind of distortion of contents. And furthermore, we introduce a novel loss term to the holistic loss function to urge the reconstruction process into an identity-aware state. The reconstruction phase is transformed using the state-of-art impending network Edge Connect. So Edge Connect is structure-guided network combining edge inference and content impending. The edge predicted can significantly help the impending process because the structure information is well preserved. And the reconstructed area can be to some extent derived from the upper valley clues. So an identity consistency from the reconstructed faces to the original input significantly controls model's performance. Therefore, we embedded a pre-trained face recognition network, which is fine-tuned on FaceNet, a state-of-art facial recognition model. The identity loss can be calculated from the comparison between the impending face and the original one. So ReCalc in equation 1 denotes the recognition model, while XGT refers to the ground truth image, and XRecons refers to the reconstructed image. The holistic loss function is shown in equation 2. We tested different lambda ID, which is the weight parameter to the identity loss, and finally determined that 50 is the appropriate parameter to adjust the identity consistency. A celebrity faces dataset published on Kaggle was used for this research. After we removed some low resolution and poor quality images and like cropped out some redundant faces except for the target one, we have over 8,000 images for exactly 105 classes. This research didn't involve mask detection phase. Therefore, we generated binary masks directly through the transformation of landmarks extracted, rather than to add a virtual mask sticker to the unmasked phase. So as for the generation results, we randomly selected every 5 images from 5 different identities in the test set and arranged the one-choose images, masked images, reconstructed edges, and the reconstructed images horizontally for result without applying identity loss and the result from IdReco. So as arranged in the figure, it appears to be difficult to visually compare the same batch of samples on picture quality, because we assume this is because the proposed method doesn't optimize the original network structure, but adds an identity bootstrap term for higher identity conversions. However, we can state that the structure-guided network can generate high-quality images, and the introduction of the identity loss is not misleading in generating these kind of high-quality images while optimizing the model. The recognition phase was based on comparing the distance in the projected feature space. We tested the projected distance between both the result without identity loss function applied and the result from IdReco to the ground truth phases. We defined a strict threshold of 0.5 and compared the nearest distance to this set threshold to evaluate the confidence level of the results, where the results like with a distance of over 0.5 will be treated as unknown identities. As shown in table 1, the reconstructed images attain an accuracy 50% higher than the unprocessed masked images, whereas the accuracy from the pipeline with identity loss introduced was improved further by 4%. Yeah. So to further test the effect of identity loss on the consistency of identity, we randomly selected reconstructed images for of the 2 different identities from IdReco and also the model without identity loss introduced, respectively, and fed them into the face recognition model to extract the features. We tested the projected Euclidean distances from the extracted features to their ground truth images, and found that IdReco performed better in terms both consistency with the same identity and the alienation from different identities. So in addition, the inclusion of identity loss can contribute to the overall separability. We use TSNE to reduce feature dimensions to 2 dimensions. As can seen from the scatter plot, visualization of masked images were scattered and highly confusable between the clusters. The purely reconstructed faces were more explicit in the separability of most of the clusters. However, there were still some clusters that were too close to each other or kind of had intermingled clusters, while a certain cluster is suffering low coherence inside the cluster. With the addition of loss ID or identity loss, both of the separability between the clusters and coherence inside one cluster are significantly improved. So using the proposed method, we implemented edge-guided method to reconstruct a masked lower phase to make the result realistic and structurally consistent, and thus improve the recognition accuracy. In addition, we also introduced an identity loss term to further improve the model performance by enhancing the identity consistency. The introduction of the identity loss term, as described in the evaluation section, improved the convergence of identical phase and the separability between different identities by backpropagating the model toward more robust reconstruction, which shows that the proposed method achieves a better preservation of the identity features. The use of generating methods to solve the masked face recognition problem is extremely promising, along with the well-preserved identity features. Although our approach has shown a remarkable performance so far, further improvements in accuracy and security for real applications have yet to be explored. Therefore, in the future study, we hope to apply and test the current method on a larger dataset to further observe the advantages and the problems of the proposed methods and explore more efficient and high-quality methods for identity preservation. Thank you so much for listening.